It's in the presentation mode, I believe.
Yes. Please go ahead.
Yeah. Hello, everyone. This is Sourav Bhattacharya. I work for Dun& Bradstreet as a data architect. And talking about Dun& Bradstreet, if you are in the United States, I hope you have already heard about Dun& Bradstreet. We are a 180 years old organization, and we have started our technology center last year in Hyderabad. We have largest global commercial data available with us in the planet, and we are using Snowflake in some of our projects to implement data-driven solutions. So I'm going to talk about, Snowflake offers some really wonderful features. I'm going to talk about on a high level of some of the features and overall Snowflake architecture. So these features make Snowflake really unique, very niche. So I have divided it into two sections. In the first part of it, I will talk about architecture, parallelism and concurrency, costing performance, and time travel and fail safe. And in the second part, I will talk about secure data sharing and dynamic data masking. So let me quickly start with the architecture of Snowflake. Now, Snowflake it's a bit different than the traditional RDBMS system we have. Snowflake provides massively parallel processing MPP petabyte scale database with columnar data storage. Data at rest is always encrypted and compressed in Snowflake. So Snowflake is not built on any existing legacy database platform. It built on a SQL-based query engine, and which is natively designed for the cloud. So Snowflake is a combination of shared disk and shared nothing architecture. It has a centralized data repository which provides ease of data management as shared disk architecture. And at the same point, Snowflake has a compute layer which has a different virtual warehouse, which we'll go through in detail what virtual warehouse is and how to use virtual warehouse in Snowflake. To start with, virtual warehouse is kind of a compute clusters which contains a small portion of the entire data. So this provides the performance benefit of shared nothing architecture. So that's how Snowflake has the ease of data storing of shared disk architecture and performance benefit of shared nothing architecture. It has three layers in its architecture: Snowflake architecture, cloud services layer, query processing or compute layer, and database storage layer. So Snowflake, I will go through each layers and specifically will go in detail about the query processing or compute layer. So in the database storage layer, Snowflake stores the data in an optimized compressed columnar format. As I said earlier, it internally manages the size, metadata, statistics, compression, structure, and all other aspects of the storage. Okay, we don't have to manually implement any such thing to modify any storage structure. Snowflake internally manages everything. In the query processing part, Snowflake performs query processing in this layer, this compute layer, and it to perform any sort of query processing, if you want to fetch any record from a table or if you need to load data inside a table, you need to use a virtual warehouse. For most of the operations, you, with some exceptions, of course, you need to use a virtual warehouse to perform that. Okay, now virtual warehouses we have from extra small, so they call it t-shirting and Snowflake. So from extra small to 4x large warehouses are available. There is 5x large and 6x large warehouse as well, but currently they are in preview. And for extra small, it contains one server, small contains two, then medium contains four, large contains eight, like this. 4x large virtual warehouse contains 128 clusters. Okay, so this is a single cluster warehouse. Let's say you are executing a query in a complex query with an extra small warehouse. Okay, and if you notice that query performance is not up to the mark, you can resize, but yeah, it will not always improve the performance if you resize to the next upper cluster. Okay, that depends on many other things: how many threads available, how many how many people using that particular warehouse. I will touch all these aspects, but that's how the virtual warehouse works. You can increase if a particular query is you're observing that it's not performing well, you can increase the size of the warehouse. You can resize it. Let's say you're using extra small, you can resize it to large warehouse without the need to redistributing the data, without the need to stop the execution. Okay, that doesn't mean if you are executing a query, it will immediately switch to the large warehouse. It will get completed in the extra small warehouse, and after that, all other queries will use the large warehouse if you are using the same virtual warehouse. And then comes the cloud. I will go on detail about this compute layer virtual warehouse. Let me talk about the third layer of Snowflake architecture, that is cloud services layer. So this layer manages infrastructure management, metadata management, query posing and optimization, and access control. So if you trigger any query, or if you initiate, let's say, any access control or any login ID or anything, any login request, it will first go to the cloud services layer. Cloud services layer will do the optimization, check the access control, do the infrastructure management, metadata management, and then it will use the query processing layer. It will use the resource from the query processing or compute layer to access the data present in the storage layer. So that's how the three-layer architecture works in Snowflake. Now, as I was saying, that cloud virtual warehouse in the compute or query processing layer of Snowflake. So the best practice is to create a separate warehouse based on your user base. Okay, if you have BI analytics user base, data scientist, retail processing, SQL analyst, or any other different teams, you need to create and distribute your warehouses accordingly. It's not like that you will create a single warehouse and everyone else is going to use the same warehouse. Okay, you need to distribute it accordingly, depending on the load, depending on the group, and depending on the type of operation they are using. Okay, your data scientist might need a bigger or larger warehouse, but BI or analytics might not need. They might need only small warehouse. Okay, so Snowflake is I will discuss in detail about the costing part, but it has, to start with, it has this compute cost and storage cost is separate. Snowflake bill asks for compute only for the time period a virtual warehouse is up and running. And a virtual warehouse provides instant scalability. Okay, you can anytime scale up and scale down in warehouse, and it's just no lag, no downtime. You can simply increase the size. That they call it scale up. Okay, and sometimes it has observed that, okay, if it's a single complex query and it's taking longer time, you might need to resize the size of the warehouse to the next upper warehouse. Okay, that's a virtual warehouse. That's scale up. And sometimes there might be an increased load on, let's say, the number of users got increased and they are trying to use a single warehouse to access data from a particular table or multiple tables. Okay, they're using the single warehouse. So in that case also, the query performance, some of the queries will be in queue. Okay, to get rid of the situation, we need to use multi-cluster warehouse, which will provision a similar, let's say I have an extra small multi-cluster warehouse with minimum cluster size 1 and maximum cluster size 4. I can define that at the time of warehouse creation. So it will start with one cluster, one virtual warehouse, and if in case of increased load, Snowflake will automatically provision another extra small cluster, and it will go up to 4 extra small cluster, as the maximum cluster count I have mentioned as 4. And in case of when the load got decreased, it will automatically remove that extra provision cluster and it will bill us accordingly. So this particular process, they call it scale out. Okay, so that's how scale out and scale up works depending on the situation. We need to use this to improve performance and balance between cost and performance. So this is how the warehouse creation window looks like. You need to enter, once you click on that create warehouse thing, this window will pop up, this form will pop up, and you need to name the warehouse. You can select from this drop down the size of the warehouse from extra small to 4x large. You will see here, and Snowflake automatically prompts that, okay, this particular warehouse is appropriate for this much amount of data processing. And in case of multi-cluster warehouse, in case of single cluster warehouse, the maximum cluster and minimum cluster would be 1. And in case of multi-cluster warehouse, there will be a minimum cluster count 1 and maximum cluster count can be up to 12. Yeah. And that's how Snowflake, in case of increased load, Snowflake will start provisioning a same size of an extra cluster. That's how multi-cluster warehouse works. And it has two different type of policies. One is standard, another one is economy. In case of standard policy, when we execute some queries using a multi-cluster warehouse, and if Snowflake system detects that there are enough queries to occupy this particular warehouse, it will provision another extra small warehouse as part of multi-cluster warehouse scale out. Okay, but in case of economy, it will wait till 6 minutes. It will see that whether the current load is enough to go beyond that 6-minute limit. Okay, after that only it will provision. So that's how economy and standard work. If you need immediate provisioning of an extra cluster, you will use standard. But if you need to use it in a budget way to manage the cost, and at the same time, if you shouldn't wait, you need not wait for a longer period of time, you will select the policy type as economy. And it has auto suspend and auto resume. So we can auto suspend a warehouse that when that particular warehouse is not being used, it will get suspended automatically based on the time period. If you mention it as 5 minutes, so in case of 5 minutes of inactivity, it will automatically suspend that warehouse. And if you check that auto resume, so if someone is trying to use that particular warehouse when executing a particular query, it will automatically be up and running. There is a separate thing as mode in multi-cluster warehouse if we need to use it in scale up mode or in maximize mode. So the scale out mode is first it will provision one cluster, and then depending on the max limit and the number of queries, it will slowly start provisioning another cluster. But if we use it in a maximize mode, which is the minimum cluster size would be 10 and maximum cluster would be 10 or 5 or 5, whatever you decide. Okay, the minimum cluster and maximum cluster would be more than 1. And when Snowflake start this particular multi-cluster warehouse, it will start with all the clusters so that you can get the optimum maximum possible resource users. Suppose you have a requirement where you have too much of load and you need to use the warehouse in maximized state always. So you will use it like this in a maximized mode. So that's all on a high level in data warehouse. I'm sorry, virtual warehouse in Snowflake. So here is an example we have performed with respect to parallelism and concurrency. So in case of a 1.3 GB file, if we load that file into Snowflake, it will approximately got loaded in 42 seconds of using extra small warehouse for 5.8 million records, and data within the table, as I said, that it will always be in compressed state. So it is around 320 MB in Snowflake. Okay. But again, if we need to use the parallelism, we can split it down. So the recommendation from Snowflake is we need to use from 10 to 100 MB file size. Instead of having a single file of 1.3 GB, we can split that file into 20 different files. And if we trigger the load, it will got loaded within less than 12 seconds. Similarly, if we create, let's say we are executing 8 different queries using a particular virtual warehouse. Okay, and for the heck of it, let's consider that each query takes 40 seconds to get completed. Okay, now for 8 queries, how much time it takes? If we split, and let's say 8 is the maximum query that warehouse can contain. More than if we trigger more than 8 queries, that will be in queue. So instead of doing that, if we use 2 separate extra small warehouse, and if we trigger 4 queries in warehouse 1 and 4 queries in warehouse 2, it will be completed in much faster way. And that's how we can use the parallelism and concurrency in Snowflake. Other than scale up and scale out, Snowflake also provides clustering. So by default, the data in Snowflake is in clustered, stored in a very clustered manner. But for a long period of time, if we trigger continuous DML in a very large table, there might be a need to recluster or use a clustering key from our end instead of using Snowflake's by default micro-partitioning. So the only for the multi-terabyte tables, it will be beneficial. You will see performance improvement if your data is less than multi-terabyte. There is no point using clustering. Will not see much of benefit in the performance. So this is an example like this. This is the table, and Snowflake stores it in original micro-partition like this. So 2, 4, 3, 2, 2 like this. Snowflake stores. And the date also it has stored in a sequential way. But if we alter this table and do a cluster by date and type, then Snowflake clusters the data differently. So Snowflake stores the data on a specific date and type in a single partition, which will help to improve the performance. So this is a graphical representation. I have prepared this particular presentation and this entire presentation by using informations available from the Snowflake documentation. And this particular presentation, no way try to override any component or any theory mentioned in the Snowflake product documentation at any given point of time. That is the latest and greatest source of information. Okay, so as I was saying that if we use that cluster by date and type, so like this, Snowflake will store the data, and this is how it will improve the performance. So as per convention, we need to use the cluster key only those fields which are being used as a filter, okay, actively used as a filter column. Only those columns, if we use in cluster by, will get maximum performance benefit. And if we still have provision to add another column as a cluster key, we should use the join predicates. Now let us talk about the cost. So Snowflake has two types of pricing strategy: on demand and pre-purchase capacity. So in case of pre-purchase capacity, you will pay beforehand and purchase a particular amount of credit. So there is a lot of scope of negotiation. And in on demand, Snowflake charges on a high level $40 per TB per month, and in pre-purchase capacity for storage, Snowflake charges $23 per TB per month. And in case of standard, so Snowflake has a few different type of editions: standard edition, enterprise edition, business critical edition, virtual private Snowflake edition. So each edition cost is different, and obviously features are also different. There are a few different things, and based on your requirement, you need to choose what type of Snowflake edition you're going to use. And for compute, this is how it charges $2 per credit, like this per hour. And then this is how against each virtual warehouse, each type of virtual warehouse, this is the credit per hour I have captured. And cloud services layer, if we use cloud services, if we use our compute, and our cloud services uses is within the limit of that compute, like within not more than the 10% of that compute uses, it will Snowflake will not charge anything. But if the cloud services is more than 10% of the daily compute, there will be extra charge. So I'm going to talk about fail safe and time travel. That will also add up to the storage cost. Not only the data you're going to store in a table, the files you're going to place in your internal stage, external stage, everything will come up, add up the storage cost. So this is the continuous data protection Snowflake provides using time travel and fail safe. So continuous data protection is, let's say, as an example, you are creating, you have a table and you are triggering DML operations on the table, and each time you fire a DML operation on the table, there is a new copy, new version of the table being stored. That's how time travel manages the data. So there is a parameter retention period. Based on that, it can be maximum up to 90 days for enterprise account and higher, and you can reduce it from 90 days to 7 days, and for a particular, it cannot be zero for an account, the time travel period, retention period, but for a particular object like table or view, you can reduce it to zero. So there will be no time travel associated against that particular table. But on an account level, we cannot turn it off. Okay, we need to manage it accordingly, and we can use the time travel, like we can go back in time to fetch the data. If we have 90 days time travel enabled, we can go back and select the data at any particular time. We can use the time travel in the DML operation as well. Let's say we have a table and we want to compare the data of today's date and maybe 5 days back. Okay, so we'll select from this and we can compare the data from, we can compare it with another select statement at a particular timestamp. Okay, we can clone using time travel as well. We can drop any table of view if it has been dropped accidentally or intentionally by using time travel undrop feature. Failsafe starts immediately after the time travel period ends. Failsafe is for 7 days, and it's not a data, it is a data recovery process, of course, but it's not being used as a backup. Or so time travel can be triggered by developer. We can trigger time travel, we can use time travel, we don't have to do anything to use time travel, but we cannot use failsafe on our own. We need to raise a ticket to Snowflake, and Snowflake will use failsafe. So this is only this is to be used, failsafe option to be used in case of extreme operational failure. It's not a regular data recovery process.
Sourav, sorry to interrupt. Quick time check. You have 5 minutes left in your session, please.
Yeah, sure. So now we'll talk about the second part of this presentation, which is data sharing and dynamic data masking. So by using secure data sharing, we can share data account to account across business ecosystem. So there are 3 different ways we can use this sharing: direct share, and then data exchange and data marketplace. So by using direct share, we can simply create a share, add a consumer to it, and consumer will get a read-only access to that data. And by using this read-only access, consumer can use that data, but there will not be any extra storage cost because it will be the reference to the consumer. The storage cost will be only once, and at any time, if there is any changes, any modification in the provided data, it will automatically immediately be reflected at consumer's end. Okay, so it will be a real-time data sharing like that. Okay, and if suppose there are consumers who doesn't use a Snowflake account, and as a provider, I want to share my data with the consumers who doesn't use Snowflake. So Snowflake provides us the provision using reader account. We can create a reader account and can give them that end consumer who's not using Snowflake that link. By using that, they can get read-only access to the provider share. And in this process, the cost is billed to the provider. And this is how the reader account look like. If you select this account button in this reader account section, you can create the reader account. You will get the URL, and you need to share that URL with the consumer who is not using Snowflake currently. Now, let me talk about the data exchange. So data exchange is your own data hub by using which you can decide who is going to consume your data, who is going to publish data in that exchange. So let's say you have different suppliers, customers, analytics team, vendors, and you want to create a data hub with your sales data, finance data, operations data, or machine learning data, or maybe any other data you have available. You can create listings in that exchange, and you can invite people who can access that data, be it your supplier, your customer, your analytics team, or your vendors within your organizations. Okay, so you can create, as the name suggests, you can create an exchange, and there can be two different type of listing access: standard access and personalized access. So in case of standard access, it normally hosts aggregated data, not customer specific data. So anyone who is having access to that exchange can access that particular data. It doesn't necessarily need any access approval. But for customer specific data, we can create personalized listing, and by using personalized listing, they need to request beforehand to get the approval, and once post approval, they can only access that listing. Another feature is data marketplace. In this data marketplace, all other companies, different organizations who are part of the data marketplace are hosting their data set, and they're monetizing their data by using this data marketplace. So let's say you are doing a sales analysis and you have observed that on a particular time period there is a dip in your sales. You want to understand whether there is any weather impact or any catastrophe impact there or not on that particular time period. Let's say you're checking for August 2020. Okay, now you need to see August 2020 weather data for that particular geography. So earlier you need to get the data from some external vendor. You need to establish the data pipeline. You need to load the data in your system, and after that only you can compare it with your data so that you can check whether that particular time period has any weather impact or not. But now you can simply log into Snowflake data marketplace. You can see whether there is any weather data listing is available, and you can request to get the access of the data, and post approval you can immediately use that data to join or to club with your data set to analyze whether there is any catastrophe happened during that period or a natural calamity happened during that period. So you can analyze within weeks instead of months. That's how data marketplace is helping to fast track the data analytics. Now, the last topic is dynamic data masking. So dynamic data masking provides column level security. So it's kind of, let's say I have a sensitive data. I have email information or PII information, which I want to, because of GDPR or any other data protection rule, I want to hide that information. I want to establish a mechanism where everyone will not be able to see that data. So Snowflake provides us an easy option of creating a masking policy. We can create a masking policy and can attach that masking policy to that particular column. And this is how the view will look like. So I have created this example with 3 different views: account admin view, system admin view, and data analyst view. And as this is how the masking policy look like. So account admin will have complete access to the email, and then sysadmin will have access to the domain part, only to the domain part of the email, and data analyst will not have any access. You will see it as asterisks. So once I create that masking policy, I attach that masking policy to this customer email, and then if account admin queries that particular table, he will see entire information. Sysadmin will see only the domain, and data analyst will see all asterisks, completely masked data. That's how we can provide column level security by using dynamic data masking. So that's all on a high level. I have explained the Snowflake features, which can be used as data warehouse or data lake implementation or any end-to-end data marketplace using data sharing or to establish consumer provider scenario. Thank you.